In the last video, we introduced the idea of a complex conjugate to you. It's a situation where we have two binomials that have the same terms but opposite signs. So what I want to do is quickly just go back and review and show you some times where you've actually seen conjugates before. So if you recall working problems such as this, we have x plus 2 and x minus 2. And so when we create the distributive process here, we get the middle term values that are going to eliminate each other. That's what happens when you're dealing with conjugates. And if you recall, we called these sets of conjugates difference of squares. And so you can think of conjugates as being difference of perfect squares. Now, we took that a little farther whenever we were simplifying radicals, and so we had a situation where we had, maybe 1 plus the square root of 2, and we wanted to offset that radical, so we took the conjugate, and when we multiplied these together, we ended up getting negative square root of 2, positive square root of 2, and then we get the square root of 4. And of course, again, this middle term is canceling out, leaving us 1 minus the square root of 4, which we know is 2, and then we would end up having just simply a negative 1. And the process has eliminated the radical. The same thing takes place with complex numbers. When we have an imaginary number in the problem, we can use complex conjugates to actually eliminate the imaginary number. So if you look at example problem number 4, we have a situation where we're dividing complex numbers. We have a complex fraction, if you will. And you can see we have 1 minus 2i. Now, you may think to yourself, why does this need to be simplified? If you would think about it, this value of 1 minus 2i is the same thing as 1 minus 2 times the square root of negative 1, because I equals the square root of negative 1. And if you recall from simplifying radicals, we cannot have a radical in the denominator. So having an I in the denominator of a fraction is the same as having a radical. We must get rid of it. And we must do that by rationalizing the denominator. Now, the way we're going to rationalize the denominator with complex numbers is the same way we did with radicals. We're going to use the conjugate. So if you look to the solution of this, you can see that we've chosen 1 plus 2i to offset the 1 minus 2i. Now, not only do we get a situation where we cancel the middle term, 2i minus 2i, we also have the I squared, which is going to turn into negative 1, and that is going to eliminate the I term across the denominator, leaving us simply with 5 as the denominator. Now, as a final part of simplifying these types of problems, you must write the final answer in standard form, which is a plus bi. And you can see here, negative 1 plus 13i over 5. Having that common denominator actually combines those two parts together, and we want them to have them separate. And so when we separate them with the denominators, we're actually separating the real part from the imaginary part. So what I'd like you to do now is, sample problem number 4 has a part A and B. See if you can use the complex conjugates to offset or eliminate the I from the denominator, and then write your final answer in standard form. Okay, so let's see what we did here. We're going to multiply 1 minus I as the conjugate to the denominator, and so that we don't change the value of the fraction, we have to do that on top as well. That's rationalizing the denominator. We're basically multiplying this fraction by a form of 1 so that it does not change the value. Now, if it makes it easier, I tend to put things in parentheses so that I can see the foiling or the distributive process take place. And so in this case, we're going to get 2 minus 7i, 1 minus I, and do 1 plus I and 1 minus I, and I have them side by side. And this allows me to kind of see everything like a normal problem. And so let's work these out. Now I need to combine the like terms on both the tops and the bottoms, and also deal with substituting for the I squared. So that'll leave me this. And when I finish combining like terms, I finish with negative 5 minus 9i over 2. And in order to write this in the standard form for complex numbers, I must separate that denominator. And it's okay to have a negative in the middle. That's in the standard form. That's appropriate. If either one of these fractions could be reduced, you would also need to reduce the fraction for it to be in final standard form. Okay, so let's take a look at part B. I'll go ahead and work it out real quick, and you can come back and take a look at it also. Okay, and so that is how we can use complex conjugates to help rationalize the denominator whenever we have an imaginary number in the denominator.